Have you ever stopped to think that absolutely everything in the universe is in motion, constantly turning? The moon orbits the Earth, while the Earth spins on its axis and at the same time circles around the sun. But even the sun is not still. It follows a path around the center of our galaxy, the Milky Way. And the Milky Way itself moves as well, orbiting the gravitational core of the so-called local group, a cluster that includes more than 50 galaxies. All of this is also revolving inside an even larger structure, the Virgo supercluster. It's rotation within rotation, like an endless cosmic ballet. Even our space missions depend on this universal principle. Before landing on the moon, spacecraft must first establish orbit, not only around the Earth, but also around the moon, before making a controlled descent. Rotation is essential to navigation in space, and it's not just about planets, stars, and galaxies. On the smallest scales, in the realm of quantum physics, spin also exists. Electrons orbit the nucleus of atoms, and beyond that, every subatomic particle carries a property that physicists call spin. Spin functions like the DNA of motion. It's not literally spinning in the way we picture a planet rotating, but rather an intrinsic form of angular momentum, as fundamental as mass or electric charge. In the case of electrons, this spin generates tiny magnetic fields. Protons, neutrons, and even antiparticles all have spin as well, and this characteristic is inseparable from them. From the moment a particle is created, it already possesses this intrinsic property, which depends on its density and energy. As matter accumulated under gravity to form larger structures, stars, planets, and galaxies, these bodies naturally inherited angular momentum. This momentum determines whether an object rotates on its axis or revolves around another, like Earth orbiting the Sun. This tendency to spin also explains why celestial bodies adopt spherical shapes. Gravity pulls mass toward the center, and the larger the mass, the stronger its pull, while angular momentum distributes the motion evenly. You might ask, why don't planets simply crash into each other? The answer is that if everything were motionless, gravity would indeed pull all matter into a single point, causing collisions and chaos. But nothing in the universe is at rest. Everything is moving, and because these velocities differ, a cosmic choreography emerges, guided by a powerful principle: inertia. Inertia is the tendency of a body to remain in motion or at rest unless acted upon by an external force. In the vacuum of space, where there is virtually no friction, motion persists for immense spans of time. This is the law of conservation of angular momentum. It ensures that objects continue to spin and orbit, whether in circular paths or elongated ellipses. Even collisions do not erase angular momentum. It is only redistributed. This brings us to the concept of escape velocity. Escape velocity is the minimum speed required for an object to overcome the gravitational pull of a larger body. For Earth, that speed is 11.2 kilometers per second, more than 40,000 kilometers per hour. Yet even at this speed, we remain bound to the Sun, moving along in its orbit. To escape the solar system entirely, a body would need to reach 43.5 kilometers per second. That's why sending a probe beyond our system is no simple task. Take Voyager as an example. Scientists employed a clever strategy known as gravitational assist. Instead of relying solely on fuel, They use the massive gravitational pull of planets like Jupiter and Saturn to slingshot the probe, giving it huge bursts of speed without expending more energy. This technique works because energy is conserved, and by borrowing momentum from giant planets, a spacecraft can achieve interstellar velocity. Now imagine trying to escape not just our solar system, but our entire galaxy. The escape velocity from the Milky Way is staggering. 537 kilometers per second, nearly 2 million kilometers per hour. But perhaps the greatest question of all remains unanswered. Why has everything in the universe been spinning since the very beginning? Did the universe itself start with rotation? Some research suggests a subtle asymmetry, a small excess of galaxies spinning in the same direction, perhaps 1 to 2% more than the opposite. If this observation holds true, it could point to an initial spin at the birth of the universe. Some theorists even propose that this primordial rotation might be connected to what we call dark energy, the mysterious force driving the expansion of the universe. Perhaps dark energy is not an unknown substance, but the effect of a colossal centrifugal force generated by the universe's rotation itself. So far, evidence is lacking. Measurements of the cosmic microwave background, the ancient light of the Big Bang, show no clear signs of universal spin. But that does not entirely rule it out. Maybe the universe rotates so slowly that it escapes our detection, just as ancient people once believed Earth was motionless. In fact, some hypotheses suggest that the universe could take over 6 billion years to complete a single rotation. At that time scale, it's no wonder it feels motionless to us. And if we take speculation even further, what if our universe itself is turning within a greater structure, just as planets orbit stars and stars orbit galaxies? What if the multiverse is a vast system of universes, each rotating, colliding, and giving birth to cataclysmic events like the Big Bang? The truth is, we don't yet have a final answer. But what is certain is that the universe is never still. It is alive with motion, a vast mechanism where everything spins, and we humans are just tiny parts of this immense cosmic machinery. If you've enjoyed exploring this question, don't stop here. Subscribe to Cosmic Mysteries and join us as we continue uncovering the secrets of the cosmos. Leave your thoughts in the comments. Why do you think everything spins? Share this video with someone who loves astronomy. And together, let's keep looking up. Because every time we gaze at the stars, we are witnessing the eternal dance of the universe.